All right. So before we actually go over the homework, I do want to make an announcement. As of right now, they gave us the Regents schedule, so that makes us believe there is a Regents this year, which will be some of your first major tests you've taken. If you were one of the kids that opted out of your elementary and middle school state tests, this will be your first big test you're ever going to take, which is slightly terrifying to me and maybe to you too. I'm not sure. The reason I say it's slightly terrifying is because you have to sit for 3 hours without your phones, which you won't need to use your brain for 3 hours in earth science. You just can't use your phone for 3 hours in for the earth science test. Yes, you get 3 hours to take the test, but you don't have to use it. I have literally seen one kid my entire career use the full 3 hours, and that person turned out their first language was not English. And they did not tell me till the day before the test. What they did was translated the question in their head first, then wrote it down in their, thought about it in their own language, then translated it into English. So basically he was doing 4 times the amount of work that he needed to do. And of course that's going to take a long time. Still did excellent on the test, but he's the only person I have literally ever seen take the full 3 hours on the test. So I'm not worried about you using your brains for 3 hours. I am worried about you guys not touching your phones for 3 hours. And you can't do music. So see, that's what I'm saying too. You guys, that's my concern. I am not concerned about you taking the test at all. I am literally concerned about you able to function for 3 hours without any form of entertainment. Yeah.
Let's say hypothetically World War III starts.
So hypothetically, I've never heard of anything like the COVID virus messing things up before. So I have no idea. No, so I have no idea. There's still a possibility the state might change their mind or how these work. I don't know. But as of right now, and you should probably write this down. And the other thing you should probably do is tell your parents about this, especially if you are a person, your family schedules vacations. Because up until this, it looked like you were done with school. Like according to the calendar, we are done. And by the way, so today, if you include today, there are 47, nope, we're on Thursday, there's 45 more class days. So it looks like on this calendar, you were done with school on June 13th.
Wait, so what are other minutes?
I just said that the Regents exam is, I haven't even gotten that far. So you really haven't missed much. So from telling you as of right now, there's a Regents exam. So your last day of classes is Monday, June 13th. However, as of right now, this year you have a week and 4 days after that of Regents exams. I know when mine is, when Earth Science is, it's Friday, June 17th. So please let your parents know that you still have school despite the fact that the calendar makes it look like you're done. Here's how it works, or at least how it's worked in the past, is you have to take the Regents to pass the class. End of story. You have to take it. Carly asked me, well, she's a little nervous about passing it, which I'm sure a few of you are. This year, I don't think you have to pass. I know there's ways around it if you don't pass the Regents. But if you don't take the Regents, that's different than not passing. So as I tell my daughter when she gets mad because she doesn't turn in her homework, but I still have a good grade. Yeah, there's a big difference between earning a bad grade and getting a 0. So you still have to take the test. So you can't just not show up because you're like, it's not like those 7th and 8th grade and elementary tests where you can opt out. That is not a thing in high school. You have to take these Regents if you plan on graduating. This year, because of the way things have worked out, you technically don't have to pass them. Doesn't mean you shouldn't aim for passing them, but you do have to take, not necessarily pass. There's a difference. Speaking of taking the regents, remember at the beginning of the year in lab, I mentioned you have to earn a certain number of lab credits to take the exam. So it's like pretty much all of them. There's a little bit of wiggle room, but it's like one or two like of the 1 dayers. So it's not like even one of the 3-day labs. Like if you're missing that, you aren't eligible to take the regents. So even if you are missing the very first lab we did, that counts. Even if you got hundreds on every lab you've done, except for you got 164, you can't take the regents. So I know that from my lab students, I've been keeping up on you. I've been messaging parents when you're missing more than one. I don't know what Mrs. Staley's been doing, and I don't know what Mr. Miga's been doing, but you are responsible too. So if you're missing 1 or 2, you need to get your butts in gear. Even if it's from the first quarter, you still need to turn it in. So don't slack on that. That would suck if you've sat in this class, especially if you've sat in this class and you're passing this class and then can't take the regents because you didn't turn in a lab in October. So please make sure you get that done. Again, the regents here, I have the schedule right here. So the regents for earth science is, it says 1:15. Do not write that down. Just write down that it's in the afternoon. I think it's more like 11:30-ish. But please make sure your parents know that the earth science regents is Friday, June 17th. What other regents do you guys take? Do you take the global?
I think so.
I think so too. So that looks like that's in the morning. Okay. So, and Mr. Crucci's a global teacher, correct? Yeah. I'm pretty sure you're taking this. So it looks like you'll be here all day, which is kind of good because you don't have to come in again a different day. How it works is there's a bus that will pick you up in the morning and a bus that will take you home in the afternoon. So you don't have to worry about that. Do you guys take, what maths do you take? Geometry. So it looks like you also has your math teacher talked about having a regents? So geometry has one on Tuesday. There's none on this Monday, because that is June 13th test, but so we'll continue to talk about this. One other thing is that you have a lab regents this year too, but that will be in school during your lab period, unless you're a person who gets extended time or test run or anything like that. We'll figure out when it is, but it'll still be during school. All right, any questions about the regents or anything? Okay, I'll leave it at that. It is what it is. All right, let's go over the homework. This first question right off the bat, I know probably threw a few people off. Says the graph to the right shows the average concentration of ozone in the Earth's atmosphere over Arizona during the 4 months of the year. Which layer of the Earth's atmosphere contains the greatest concentration of ozone? So you had to look at the chart. You can see that concentration is on the X, altitude is on the Y, and yes, they do miles and kilometers. So what you had to do is follow these lines. In February, the concentration started over here near like 1. As you go up in the atmosphere, it gets highest over here. So it's got a concentration of about 11, but it's in the atmosphere around 10 miles. Here's the highest concentration during August. It's over near 17 miles. And during this one, looks like November, it's just below 15. And then there's another one right there just above 10. So the highest concentrations are here between 10 and 17 miles in the atmosphere. So what layers are those? You had to use your reference table, page 14. So 10 and 17 miles, that's in the stratosphere. Again, be careful if you're using miles or kilometers. An air temperature of 95 most often exists in what layer? So 95 is not on here, but 100 is. So we're just a little before that. And the only time the atmosphere gets up to near 100 degrees Celsius is in the thermosphere. Greatest atmospheric pressure occurs where? So pressure, remember, it starts at 1, goes up to 0. So where is it 1? At the very bottom of the troposphere. As the elevation in sea level and Earth's atmosphere increases, the measured pressure will. So as we get higher, what happens to the pressure? Decreases. Which part of the atmosphere has the smallest distance from top to the bottom of its zone? Distances can be figured out by altitude. The troposphere goes from 0 to about 7 miles. The stratosphere goes from about 7 to 30-ish miles. The stratosphere goes from 30-ish to 50-ish, and the thermosphere extends to 600. So which one's smallest from top to bottom? Yeah, this troposphere is clearly the shortest. Nearly all the water vapor is found within the troposphere. We did that yesterday. And which statement most accurately describes the atmosphere? I love this question because they say most accurately. When they say most accurately, some could be kind of true. Yeah. So some could be kind of true, but only one of them is most accurate. Can you guys read all 4 and tell me which one you decided was more or most accurate? Two is pretty good. I like 2. Is it the most accurate though? Probably number 1, you're right. The atmosphere is layered, which we know, and each layer possesses its own characteristics, its own temperature, its own pressure, its own water vapor content. With 2, it is true up until we get to this most of Earth. Guys, the atmosphere surrounds all of Earth. But yeah, almost everybody would have picked 2 because of the part where it just starts with the shell of gases. That was legit how we defined it. So always read all the words. All right, ozone in Earth's atmosphere is concentrated at 20 to 35 kilometers. Which layer is that? So again, make sure you read the kilometer side. 20 to 30 kilometers, that's in the stratosphere. Notice if you did 20 to 30, well, that still would have given you, is it 20 to 35? That would have put you in the mesosphere if you used miles. So please make sure you read that carefully. That is the stratosphere. What is the approximate temperature of the mesosphere at an elevation of 68 kilometers? Again, make sure you're on the kilometers. That's this side, 40, 50, 60, 70. So we're right about here. Go over. Was it 78 or 68? 68, sorry. And go down. We are in between negative 55 and negative 90. Oh, I must have done something wrong. 68. No, I'm not wrong. Okay, so they thought 68 was a little lower than me. Go with negative 55. What is the approximate altitude of the mesopause? So mesopause right there, either 50 miles or 80 kilometers. 82 kilometers is the closest answer. And the stratosphere ranges from, so here's the stratosphere, it starts at negative 55 and goes up to 0. And 75 kilometers, where is that located? So there's 80, so 75 is right below that. That puts you well into the mesosphere. And then we switch over to ESRT page 1. Most abundant element in the troposphere. Troposphere is here. Most abundant means the most, that's nitrogen. Now, most abundant by volume in the hydrosphere, so hydrosphere by volume, most abundant is hydrogen. And if these are in the Earth's crust by mass, what are these two letters? Earth crust by mass, the two biggest are oxygen and silicon. And Earth's troposphere, hydrosphere, and lithosphere all contain relatively large amounts of, well, is it iron? No, because the hydrosphere and the troposphere don't have iron. Could it be hydrogen? No, because the crust doesn't have hydrogen. Could it be oxygen? Yes, it could. Let's double check. Could it be potassium? No. Any questions? I know I just went kind of fast and didn't wait for any questions. Anybody have any issues with any of those? All right, let's move on then. So yesterday we talked about the difference between internal and external energy. Today we're going to be talking about heat transfers. Guys, what does the word transfer mean to you? Okay, so how they move from one to the other. So this is really how heat moves. And like we always do, but oh crud, I copied this wrong. We are going to do the reading, but we're not reading just for fun. We are looking for the description for each one of these. We're going to be looking for radiation, conduction, and convection. So a description, basically a definition of each one. We're going to be looking for which phase of matter heat moves through. Do you guys know what I mean by phase of matter? Solid, liquid, or gas? You're going to give me an example and we can draw a picture together. We don't need to get that all on our own right now. So what I want you to do is either grab a highlighter or grab a pen or pencil, and I'm going to have you go through this reading looking for the definition of radiation, the definition of conduction, and the definition of convection, all from this reading. Should we read it together or you want to read it on your own? Anybody else or just Tucker have an opinion? Okay, so I'm hearing on my own. So again, you're reading page 7, and we're just doing the top chart on page 8. That's it for now. So go ahead and do the reading. All right, so we are going to fill in the top of page 8. For radiation, did you find a definition for radiation? It is the transfer of energy in the form of waves. Top of page 8. And Megan, you gave it away for the phase of matter. What phase of matter does radiation go through? Yeah, it goes through air, she said, so it does go, oh shoot, I went the wrong way. All right, for the next one, we'll do conduction first. It is how energy is transferred from one hot molecule comes in contact. That is the key with another molecule. And convection, we have done convection already like 4 times. Does convection transfer energy? Everybody go back to, yes. So convection It's the transfer of energy from one place to another when the heated molecules move. That's it, 3. So, hey, Tyler, what do all 3 of them have in common? They all transfer energy. All right, and we already said the phase of matter for radiation, that is only ever through the air, only ever through gases. How about conduction? Is through solids. Got to touch something solid for conduction. How about convection? Technically, solids will work too. Think of the earth itself. So it is all 3 of them, but mostly just liquids and gases. What is a good example of radiation? Oh, I hesitate with that because that is nuclear radiation. It's a little different. Let's stick with something simple that we've all experienced in our real life. The sun, or heat from a fire, or even your own body. So I'm going to go with heat from a fire. You could do heat from the sun. For your own body, if you hold your hand next to your face, especially if you were to just go run the mile and hold your hand next to your face, what would you feel? You would feel the heat coming off of your body. With heat from a fire, do you actually have to touch the fire to feel the heat? The sun, do we have to touch the sun to feel the heat? No. So if you could draw yourself a quick picture here, my picture would be pretty bad. I would probably show like flames if I could, and then a stick figure holding their hands over the fire. Now, how about conduction, where you have to, one molecule has to touch another molecule and it has to go through solids. Okay, a fire. No, because you're still feeling the heat, the energy is still, I see where you're going with that. Again, let's think of something in our everyday life. Touching a hot pan. The handle on the hot pan. If you are making macaroni and cheese and you leave a spoon in the boiling water, the spoon is going to get hot. The pan is going to get hot. The example I had in there was like, I set a fork, or no, I set a hanger, a metal hanger, cooking a marshmallow or a hot dog over a fire. I was trying to imply, you know, those marshmallow cookers, like the marshmallow roaster, a metal one without a good handle. So that's what I was trying to imply. I just couldn't like make that come across in words. Even wooden spoons, they don't conduct well, but they will still get warmer than anything like the nothing. They still do conduct a little bit. So I said a hot fork in a fire, or a hot pan, like you guys said. Again, do your best to draw a picture for that one. And then convection, boiling water is a perfect example. Yeah, well, convection baking is actually just an air fryer even. So that is when the warm air rises and the cold air sinks. Boiling water is a great example because where is the flame when you're boiling water? At the bottom. And then that flame, actually the flame touches radiates to the pan, then the pan touches the water, and then the water molecules heat up. And then we've got warm water molecules that then rise to the top of the pan and then sink. And to be honest, the picture I draw for convection is just an arrow going up for warm. and an arrow coming down for cold. That's as good as you need to do. Maybe put that in a pan, whatever you got. So those are the 3 ways heat is moved around in Earth's system. So we're going to take each one of these individually. We're going to start with radiation though. So we're going to again skip the bottom. We'll come back to that as a review. We're going to skip page 9 for now. Tyler already blew the secret out. Which ones are they more similar or more different? What do you think, Tyler? More similar or more different for these 3? Why? They all transfer. Who would vote for more different? You guys all would say more similar? Okay, well, I think they're more different because they all do it in very different ways, but you do you, whatever. It's not important for today. Let's do radiation. So here's the 2 things we need. 2 bullets is actually pretty much the rest of the notes. There's actually a little bit more. So we're on top of page 10, how energy reaches Earth. Energy reaches Earth through radiation. So radiation, energy from the sun, travels through the atmosphere in the form of waves. Most of the energy that reaches Earth's surface is in the visible light range of the electromagnetic spectrum. And yes, that vocab word is next. So let's start here. We're on top of page 10. So again, energy leaves the sun in the form of waves and reaches Earth in the form of waves. And this is called the electromagnetic spectrum. So that's the next bullet. It is just a classification of radiation based on wavelength, frequency, and amplitude. Then grab your reference table, page 14. All right, ESRT page, oh, ready? ESRT page 14, you will see this at the very bottom. So page 14 has 3 different charts on it. This is the 3rd and final one we're going to use. This is all called electromagnetic radiation. The sun is shooting all of these different types of waves at us right this very moment. So these are all waves. And when you think of waves, I want you to think of waves that go up and down. That's what these are. Now some of these will have different wavelengths. Some of them will have like really large spaces in between them. Some of them will go just really small spaces in between them. All you need to know, so with wavelength, so again, what I was just trying to show, we have long wavelengths or very short wavelengths. Length is the time between each peak. So, or not the time, the length between each peak of the wave. That's what a wavelength is. All of these waves are leaving the sun, and this is just how we organize these waves. You'll see there's arrows that point to the left and they say decreasing. So they are the smallest over here at gamma waves. These are the smallest. These are where the waves are going really close together peaks. Then as you can see, as you go to the right, they're increasing wavelengths. Radio waves have the longest, so they're most spread out waves. They go in order. So gamma is the shortest, X-rays, ultraviolet. Now visible light squeezes in here between ultraviolet and infrared. And then they just keep going in order. Now, have you heard of any of these waves before? Gamma rays, who know? You know what a gamma ray is? Well, what's a gamma ray? Let's start there. It's the old lady ones. What's a gamma wave?
I've heard of it.
So basically, for grandma.
It is for grandma. No, gamma rays are the, ever heard of the Hulk?
Yeah.
Yeah, how do you get?
Radiation.
Yeah, he got it through that kind of radiation. The Hulk got his superpowers through gamma rays. This is
That's
nuclear.
like for both
This
stuff.
is the nuclear stuff.
That's like leading.
Do you have room to add that little label on your reference table? Yeah, gamma rays are the nuclear stuff. Yeah, X-rays. You guys know what X-rays are, right?
Yeah.
Hey, take pictures of your bones. Now, did you know that the sun is shooting them down at us right now?
That's cool.
I can't see my bones. Why do you think I can't see my bones?
Yes, yeah.
Not because I got skin. There's X-rays shooting right down at me.
Can't see it.
It's not as much.
We're at a-
It's not like the other two.
No, that's not it. How about the nuclear? There's nuclear. It's like a giant nuclear power plant going on the sun. How come I don't look like the Hulk?
The atmosphere.
The atmosphere. The atmosphere blocks most of the harmful stuff from reaching us. What does ultraviolet do?
So it's like.
You guys heard of UV light, right?
Yeah.
What's it do? Gives you a sunburn. This is the sunburn one, which then can lead to skin cancer. Infrared scopes, infrared thermometers. What did they actually do? These are the heat waves.
They let the predator come.
Okay, the heat waves. You would use infrared goggles or an infrared scope. You can't see the actual deer or the person. What do you actually see? But you wouldn't be able to tell if the person was smiling at you through an infrared scope. You see their temperature, so they see the heat. Microwaves, like legit the microwave that you cook your macaroni and cheese in,
Really?
are being shot at us from the sun.
They go.
Again, I am not being cooked.
I don't see.
Again, because of the atmosphere, most of it gets blocked. Now, radio waves, they are the legit radio that you tune in to in your car. This is the same waves. Basically, what we do is we hijack the radio waves coming from the sun and send things out at the same frequency. That's why you have to change your radio station. It changes the wavelength and that you get different stations. Hey, quick, turn to page 11.
Then you like go into a.
Cross off question 6 on page 11 because your homework is pages 10 and 11. And then see where it says angle of insulation? That's not homework, that's notes we're gonna start tomorrow. So you're just doing the questions on 10 and 11. Not the notes, but all the questions, including the top 6 and then the next 5. So there's 11 questions for homework. Don't do the notes. So yes, I expect you to do these 6 questions for homework, the 2 here on the bottom of 10. You can cross off question 6. And then we're gonna do the notes tomorrow.